inequality is. Now, this is just pretty simple. This basically, that's a solution. But sometimes what we know is we got something like, say, 2x plus 5 is less than, say, 10. Then how do we do that? Well, in the inequality, we have addition property. That means you can add, subtract the same amount on both sides. The inequality is still true. So in this case, we can minus 5 on both sides. Then we got 2x on this side. On that side, it's got 5. Then we can divide by 2, just like we did on equality. Then x will be less than 5/2. Okay, and in the xy coordinate, this is the one dimension because we only have x. So this is a 0. And the way we're graphing it, we're graphing like, this is 2.5. So 1 here, 2 here, 3 here, 2.5. Then we're going to draw a circle on 2.5. When you draw a circle, that means x does not equal to 2.5. Then we draw a line, go this way. Okay, that's just one. Or we could have a different inequality, like say we got 4x minus 3 greater than 2. And then we add 3 on both sides, just like we did equation. Then 4x is greater than 5, then x divided by 4 on both sides. Then x is greater than 5/4. So that basically is 1/4. So we pick up 1 here, 1/4, the half, 4 is here. And we just put the circle. But in this case, we're going to on the right-hand side. So we go that way. Good. Yeah, are we good on this one? All right. Now, we also have, sometimes we have something called equal, greater and equal, or less than and equal. So in this case, for example, if we have different, then we're going to graph this in a different way. So 3x, say minus 5 less than equal to 7. Then we add 5 on both sides. Then 3x is less than 12. And we divide by 3. Then x is less than 4. So we go find 4. This is 0. This is 1. 0, 1, 2, 3, and 4. But in this case, we're using a solid circle. So like those are just circle. This is a solid circle. If we use a solid circle there, it means x can be equal to 4, and it has to be less than that. So we go to the left-hand side. That's how we draw the solution. That means the solution, what that means is x can be 4 or any number that is less than 4. Okay, are we good on this? All right, so I have you do some work. So you can just show that on the chat. So 2x plus 1 is less than 7. So what is our solution? Basically, we're trying to find x either less than or greater than a number. Okay, so that's our kind of end goal. Just like when we solve equation, we're going to just find what the left hand side is x, the right hand side is a number. Okay, see what you got here. Good job, Eddie. Okay, all right. So in this case, this is an inequality. So -1 on both sides, then 2x is less than 6. Then we divide by 2, then x is less than 3. So that is our answer because we're using inequality. So it's not x equal to 3. It's x less than 3. Actually, x is not equal to 3 because we have the less than symbol there. Okay, are we good? All right, so we're going to do 3x plus 5 greater than or equal to um, 11. Good job, Abby.
How do you type in the chat greater than or equal to?
Yeah, it just use greater than the followed by equal sign.
Oh, okay.
Mhm. Okay, so on this one, we -5 on both sides. And what we got? We got 3x on this side, greater than equal to 11 minus 5, 6. Then we divide by 3. Then x is greater than equal to 2. 6 divided by 3 is 2. Yep. Good.
Yep. I somehow thought that 11 minus 5 was 1.
Okay. All right. Um, yeah. Job, Eddie. Good job, Matthew. Very good. Okay, now we're going to looking at what happens if we divide by a negative number. One thing we notice, 3 is greater, 3 definitely is greater than 2. But if you times -2 on both sides, what happens? Then this is -6 and this is -4. So, but -6 is less than -4. So now we see that if we time negative on both sides of inequality, this sign has to flip. And we also notice that, say, if we know 4 is less than 10, but if we divide by negative number, say -2, see what happens. -2, -2. Now this side is -2, and that side is -5. Well, -2 is greater than -5. Now you can see we have to flip that. So that's when we're dealing with either multiply a negative number or divide by a negative number. We have to flip the inequality. So if we have something like this, -2x plus 3 is less than, say, 5, then -3 on both sides, then -2x is less than 2, and divide by -2, and that's where we have to flip that, positive -1. Okay, are we good on this one? Thank you, Eddie. Matthew? Okay, so I'm going to let you do a couple of those dealing with negative. Okay, so -3x plus 4 and greater than say 9, and see what you got. Good job, Eddie. Okay, so very good. So a -4 on both sides, then we got -3x greater than 5, then we divide by -3. That's where we have to flip. So x is less than -5/3. And so because we want to keep that as accurate as we can, and that is, we can either write like this or -1/2/3. Now, if we want to change the decimal, then this one actually is negative 1.666, so above. Okay, so unless they tell us to approximate, we keep them as a exact number. Okay. All right. Let's do negative 5x minus 7 less than equal to and 13. Good job, Eddie. Okay, so add 7. Then we got negative 5x less than equal to 20. Then we divide by negative 5. Now this side x, then we have to flip it. So greater than or equal to. And this side will be negative 4 because positive divided by negative, negative 4. Okay, we're good on this one. All right. Thank you, Matthew. Thank you, Eddie. Okay, so now we're going to get something even more interesting. So on this, it's just one dimension. You got x, say x greater than negative 4. You just find the negative 4. This is 0, negative 1, negative 2, negative 3, negative 4. Then we put a solid circle, and it's greater than, we go to the right. So that's pretty straightforward. And now we're going to be looking at something more interesting, is that we got something like this. Y is greater than 2x plus 1. So what do we mean by that? Well, this means that if we have a line like this, then the solution is bigger than this line here. Okay, so how do we do that? We're going to have xy, going to graphing it, the line. We'll just graph this line. And so we got x and y. Now, if we got 0, x will be 1. If y is, say, 2, then x will be 2 times 2, 4 plus 1, 5. So there's different way of graphing the line. You could just randomly pick 2 numbers, or you can pick x, y coordinate, or you can graph by the y-intercept and the slope. So, but they all come down to is to find 2 points. They just have different ways to find the 2 points. Okay, so in this case, we know this is our y-intercept, and 2, 5, 1, 2, 3, and 2, 5, 1, 2, 3, 4, 5. So that'll be here. Now, if we draw the line, and because this is a greater than, so the line has to be a dotted line, a dashed line. It's not solid. We got a line like this, which means that anything above this line is the solution for this inequality. So for example, when x is 1, this line tell us is here's 3, then y can be any points here that will meet that, satisfy this inequality. So therefore, we basically just shaded them. Doesn't matter how you do it. You could just do like this. You can do like that, or you could do shade it like this. Okay. Are we good on this one?
Yeah, but when you go to put in your answer,
Yeah.
do you have to do anything? Like you can't necessarily show that, or are you gonna have a graph on there?
Yep, you have to show a graph.
Okay.
Good. Yeah, so basically you got two forms. This is the algebraic form. And people looking at this, they understand what that means. Or you can use the graphic form on the right-hand side. It's more, kind of more visual to show what do it means by this. Good. All right. I'm going to show you another example. And so we could have y less than equal to negative 2x plus 2. Okay, the same thing, we need to draw this line, y equal to negative 2x plus 2. And we got x and y. Remember, this y is different from this y, okay? We just, even though we use the same y, but this here, this is a variable that is less than equal to negative 2x plus 2. And here, this just show us a linear function that y is equal to this. Okay, and we draw that. We can say x equal to 0, y is 2. If x is 2, then we got negative 2. Okay, I'm just kind of picking those 2 points. And or you can do x-intercept. In that case, y is 0, then x is 1. So doesn't matter which 2 point. So in this case now, first we find that the y-intercept is here, the x-intercept is here. So in this case, because we have the equal sign there, so we have to include this line. And we got line like that. And anything above that line, oh, this is the last sign, so it has to be below the line because the last sign. So will be here. That will be our solution, which means any points in the shaded region satisfies this inequality. For example, if we pick a number here, well, it says this is negative 2, this is negative 2. Okay, if we put negative 2 in there, what we got? So this point is negative 2 and negative 2. Well, plug into here, negative 2 times negative 2 plus 2, that actually is 4 plus 2 is 6. Of course, negative 2 is less than 6. But if we pick point here, this is 1, 2. 1, 2. Then if we plug in 1 here, we got negative 2 plus 2 is 0. So this point, actually, the y here is bigger than the y on the line. Okay, are we good on this one?
So then how do you know which points to graph?
Well, we just first will graph line. Good.
Yep.
And then depends on it's less than or greater than. If y is less than, just anything under the line. If y is greater than, it still be above the line. So if I rewrite this as instead of less than, right, as greater than, then my graph will be up there.
Oh, okay.
Make sense?
Yep.
Very good. Okay, so I'm trying, I'll show you just a couple more. Y is less than equal to 4x minus 5. Okay, so we do xy and all okay, we got 0 here, -5. And I can say if y is 0, then 4x minus 5 is 0, then 4x is 5, then x is 5/4, which is 1/4. So we got 1 and 1/4 here. So now in that case, what we got there is 1, 2, 3, 4, 5, -5, and 1 1/4. So half, quarter is here. So we just draw this line out. And because we're less than, so be under it. So we'll be all line here. Good.
How do you convert 5/4 to 1 1/4?
Well, 5/4, that's the improper fraction. So we know that 5/4, 1 here, 4 here, 5 minus 4 is 1. So therefore, this one goes to here. And
Oh, okay. And then your remainder is
yeah.
1. Okay.
Makes sense? Good, Matthew? All right. Now, we also have a different way of graphing the line. We have actually 3 ways of doing it, graphing line. One is just picking any, any 2 numbers. Says first one. The second one, pick 2 intercept. X-intercept, Y-intercept is the second one. And third one is based on this is our Y-intercept. You can see here. And also based on the slope to find the second point. So I'm going to show you here on this one. And that actually, the third problem way of doing it, this definitely saves a lot of time if you know how to do it. Okay, first of all, we're looking for y-intercept. 1, 2, 3, 4, 5. And we know the slope is 4, and we know the slope is rise over run. So equal to 4, we can write as the ratio, which is 4/1. That means the run is 1, rise is 4. So we go run is 1, which is horizontal distance, then go up by 4. 1, 2, 3, 4. So second point. Then we can graph like that. And or you can go, so this is a run first, then run first and rise second. So run, rise. You can also do the rise and run. So in that case, you go rise is 1, 2, 3, 4, run is 1. So you got the same point. Then you can graph that. Another way to looking at it, this basically is when x is 1, our y will be 4 minus 5 is -1, which is this point. but based on the way they're doing it, you don't have to do the lookup table. You don't have to do the table, you just find the y-intercept, then based on the slope. Okay, are we good on this one?
So where did you get the rise over run? Is that from the 1 1/4?
From the 4. Okay, not from this point. This is my using, this is the second way of doing it. Find the xy intercept. Based on the y-intercept and the slope, that's our third way of graphing it. Okay.
Okay. Yep.
Now I'm going to show you a couple more. You can see that x is greater than 2/3 x plus 2. So the nice way about the third method is we're just looking at this inequality. So y-intercept is 2, it's here. Then we go, our rise is 2, rise over run is 3. So we go 1, 2, 3, that's our rise. Then go up by 2, 1, 2. That's our second point. Then we can connect them. And then because this is greater than, so anything above that. Good?
So I guess I'm not understanding the rise over run thing. So I got the 2, but then how did you get 3 and go up 2?
Well, it's from here. This is our slope. So the slope definition is rise over run. Good?
Yep.
So the top will be our rise. Rise is, you can look at this one, 2 points. This is a direct distance, and this is a horizontal distance, and this is a vertical distance. So this is our rise, and this is our run. Good?
Yeah, but how did you know to go up 2 first, though?
Well, because this is a 2 here. The bottom
Okay.
is, so the run is 3, top is 2, so go rise 2. And it's positive, so we go up.
Oh, okay. But the two does 2 things. It goes up 2 and then you use the run and then you go up 2 more.
Different. This 2 is the y-intercept. So that tells
Oh,
this we stop.
that. Oh, okay.
Okay, this 2 tell us the rise.
Yep, that makes sense.
Okay, so let's looking at a couple more, okay? Y is less than equal to negative 3/4 x minus 1. Okay, let's do that. And we go -1. That's there it is. So in this case now, we actually, there's a 2 way to looking at this one, depends on where the negative is. You can think as -3/4. In this case, our run is 4, but our rise is -3, which means go down by 3. So in this case, now we go 1, 2, 3, 4. We come down to here, 1, 2, 3, 4. Then go down by 3. 1, 2, 3. So we draw the line like here. So that's one way of looking at. Or you can look at this at 3 over -4. In this case, our run actually is negative, so we're going to the left by 4. So we go 1, 2, 3, 4, and our rise is positive, so we go up. So 1, 2, 3. Well, I'm not drawing in scale, but if you draw in scale, you can see that. Good.
Why with your rise did you go long ways and not up?
Which one?
Uh, for the first example you did.
Yeah.
Yeah, why did you go across with x and not go down?
Well, -3 is going down, right? I go 1, 2, 3. Second point. Right?
Oh, so you use
Wrong.
4 first?
Yeah, wrong is 4.
Oh,
1, 2, 3, 4. Then go down by 3. 1, 2, 3.
okay, yep.
Make sense?
Yep.
Okay. Let's looking at y less than equal to -2/5x. Then we got +2. So how we do that? Okay, we know is 2. Our y-intercept is 2. And we know our if we write like this, 2/5, then our rise is -2. Our wrong is 5. So we go 5, 1, 2, 3, 4, 5. Then go wrong by 2, 1, 2 here. We connect that. Or we can look at this as 2 over the -5. That means we go into 5 to the left by 5. So 1, 2, 3, 4, 5. Then I go up by 2. 1, 2. So that should be like this, the whole graph. So because I'm hand drawing it, so it's not accurate. Okay?
And either one of those answers would be okay?
Yeah, because
Okay.
on this, we are drawing the same line. We just find 2 different points. Okay?
Yep.
If we think put negative on the top, then we actually find this point. If we put negative on the bottom, then we find in this point. But still, they're all on the same line.
Then what would you put your answer as?
Well, in this case, we draw the line and y is less than equal to, so that's just graphing it.
Oh, you just put the lines and that's your answer?
Yeah. Put a line and shade it out because we're talking about less than equal to. Good.
Yep.
Addy, you good?
Yeah.
Perfect. Okay. Let's try another one. Y is greater. Now sometimes we got something which is not in a different form. It could be like 2x plus 3y greater than 2. Oh, how do we do that? Well, in this case, we have to change it to the y greater or y less than form. So we're going to move 2x to the right, so minus 2x. Then we got 3y greater than -2x plus 2. Then we have to divide by 3. Then we got y is greater than -2/3x plus 2/3. So that's what we got. And then we're just graphing it. So basically we have to change it to this form. Then we can use it at the graph. Okay, we got this. And 2/3. So this is our 1. We cut by 3, so 2/3 here. And then if we do -2/3, so we go 3, 1, 2, 3, then go down by 2. So we actually go down here, 1 and 2. Then we graphing it. And in this case, the y is greater than, so all the lines on top of the line. Yep, are we good on this one?
How did you know how many to go up? Because it's 2/3. How did you know?
Well, it depends on where do you think, it's up to you. If you think this is a -3, then the 2 is -2, so we go down. Good?
Yeah, but that's for the rise over run. I'm talking from the from 0. How did you know to go up 1 1/4 or so, whatever that is?
You mean this one?
Yeah.
This is our y-intercept. So it's
Okay,
on the y-axis.
but that's 2/3. Oh, so did you take that and put it into a proper fraction?
Yeah.
Let the
This,
one.
this is my 1 here.
Oh, okay.
I cut that into 3 equal parts, and that is 2/3.
Okay, yep.
Good?
Sorry. That didn't make sense to me, but now it does.
Good question. Very good. So I'm going to show just one more, okay? Actually, the one here, I shouldn't use the solid line. That should be a shade dash line, because this is a greater than. So that should be something like this. Good. Yep. Thank you, Matthew. Thank you, Addy. Okay, let's do, we got 2x minus 5y and greater than say 5. Then we're going to minus 2x on both sides. Then -5y greater than -2x plus 5. Then we divide by -5 and -5. So this side is y. Because we divide by negative, so I have to flip it. On this side, -2 divided by -5 will be 2/5x. And then 5 divided by -5 is -1, so it's -1. So now we know our y. If we want to draw the line here, which is, this is a line here, oh God, the y-intercept is -1, and the slope is 2/5. So we can do -1. Okay, then 2/5. So we go 5, 1, 2, 3, 4, 5, then go up by 2, 1, 2. Then we draw the line. Put dash line. That gives us this. And it's less than, so it has to be below that. Good.
Why didn't you use a solid line?
Well, because I don't have equal sign there. I only do less than.
Oh, okay.
So that means it does not include the line. So it is solid. Okay.
Yep.
Very good. So that's all we have for today. And make sure to finish the homework. Okay, Matthew?
Yep, I'll get that done.
Okay. We'll see you next week.
Thank you. See you later.
Bye.
Bye. See you next week.
Bye.